Hello, welcome to openUC2. Today I have a very interesting experiment, the Abbe Diffraction Experiment. It is firstly demonstrated by Ernst Abbe to show the limitation of an optical system, and later on it came up with his famous diffraction limit formula, which describes the resolution of an optical microscope. Here's the setup. We have a torch as light source, an iris to control the illumination spot size, a 50mm lens to focus the light onto the sample holder, the sample sits inside, and a manual Z stage, which focus the objective onto the sample. The objective is a finite corrected 4x objective, which is the same as a 40mm lens, and a beam splitter splits the light into two paths. The image, this camera will have the image of the sample plane, and here is a 4F relay system, which image the back focal plane from the objective, which is also the Fourier plane, onto this camera. Now we can see the image from both cameras. Left side is the Fourier plane, and right side is the sample plane. Now we see the images are slightly overexposed, but we can see the pattern on the sample. Now we have a grid sample with grating distance of 50 micrometer. And on the left side, we can slightly see the diffraction on the Fourier plane, but not really clear. But if we close the iris to reduce the illumination, now we can see better the diffraction spots. But we see the diffraction spots are not really clear. That is because we have a white light as a light source. If we have some color filter, we can block some wavelengths. Now we can clearly see the zero order in the middle, and also the side order or first order and the other orders on the back focal plane. Now we can increase slightly the exposure time on the image camera. And we can do some experiment. I have some slit pinhole that can block some diffraction orders on the back focal plane. And I want to use that one to show you how to block some orders on the back focal plane and what will be the effect if we lost some information on or lost some diffraction orders. So now I slide it in, and you can see we on the left camera we block most of the horizontal the vertical direction orders, and on the image camera we only see clearly the horizontal direction lines or the patterns. That is because we remove the other direction images, and to make sure that is the same to the other direction, you can use another pinhole which have a vertical slit. If we slide it in again and try to align the system, now we can also remove the horizontal information on the image plane. Now we can also change another pattern on the sample. So I can increase the exposure time on the image camera. Now we see a pattern of vertical line gratings with a smiley face on it. Now you can imagine if we have a horizontal slit pinhole, if we block the vertical first diffraction orders, what will happen? Now we can slide it in. Only the zero order is passed through, and we can see on the image, we only see the smiley face because we remove all the first orders and we lost the grating information which was on the sample. So that is the Abbe diffraction experiment. The experiment shows that images are formed by the interference of diffracted light waves, and losing higher diffraction components reduces image detail and also resolution. I hope you enjoyed the video, and stay tuned. Learn optical system with openUC2.